Hello.
Hi, if you can just switch on your videos, everyone, so it'll be more fun that way. Okay, hi, I'm Hetvi. I think we already know each other. We gave a talk about math camps in the US. So today I'm going to be taking one of the topics that I actually learned there in that math camp. It's a pretty fun topic. Before I start with that, again, if I look down, I have my iPad over here from which I'm going to share my screen. So yeah. I have a question. Have you guys done combinatorics before? Do you know what is NCR, NPR,
Yeah.
factor?
Yeah.
Yes,
Yes.
everybody? Everyone?
We did it
Okay.
in this camp actually.
Okay, perfect. Okay. I'll take a little revision so that everyone knows. If I ask questions, you can just type the answers in the chat box. Yeah. And then we'll continue with the main topic. Okay. So the topic is called proof by story. So there are different ways to prove things. In mathematics, whatever statements we give or whatever facts we have, we need to prove it, right? We need to show that whatever we are talking about, it's true or it's possible. So there are different ways to prove it. There are ways to prove things algebraically, where you just use variables and calculate everything out, and LHS equals to RHS. So you have your proof. For geometry, you either construct it or you try to find out the measurements of angles using some theorems and properties and things like that. Or there's something called induction. Do any of you know induction?
That was also done in this camp.
Yes.
Yeah, Vinaysa taught us the basics.
Okay, perfect. So there's proof by induction. So this is another way to prove things. Over here, essentially what we'll be doing is we'll be given a question and we have to prove it. And to prove that question, we'll form a whole story. So we'll maybe take characters and we'll have a scenario, and then there'll be like an event or order of things that will happen in two different ways, one of which will prove the LHS and one of which will prove the RHS. And since the event is the same, it's just happening in two different ways, it will be equal. So that is kind of the idea of what we'll be doing today. Let's start with the basics. We'll go on to proving in some time. First, the basics is notation. So there are two types of notations. Which one are you more comfortable with? We have NK and this bracket, or we have NCK?
I'm okay with both.
Both, but
The right one we learned in the camp,
we
and
right
the
one
left
we learned in
one
the
also
camp, but
we are
I'm okay
familiar
with
with.
the right.
Okay, so I'll use NCK. I have already made some notes. Over there I've used this N bracket K. Just to remember, it's the same thing.
Yeah.
Okay. Now, if you've done this in the camp, you know that this is the formula.
Yeah.
N factorial upon K factorial N minus K factorial. Okay, can someone explain me why this formula works? Okay, what happened?
Can I explain it using an example?
Yeah, sure. Go ahead. I'll just figure out why the screen stopped.
So for example, we have a word with 3 letters, and there are 3 blanks for that particular word, and you have 3 letters. So for the first blank, we'll have 3 different possibilities of letters available. Similarly, for the second blank, you will have 2 possibilities, and for the third blank, you'll have 1. But in this case, if we are told that you can use, like, if we are considering so if we are considering BAD and ABD as the same word because they are using the same letters, so in that case it will be a like combination, because these both possibilities are considered the same possibility in a combination. So
right.
if we are considering a permutation here, for example, so the number of possibilities here will be 3 into 2 into 1 for each blank. So that will be 3 factorial, and for combination now, if we are why are we dividing it by r factorial and n minus r factorial is because okay, I'll take a different example because here we're already ending with 1. So if we have 4 blanks and we have more than 4 letters, for example 6 or 7 letters, then we'll not end with 1. And because of in factorial sign you have to end it with 1, so those extra numbers get multiplied, which you actually don't want. And if you want to put it in a simpler way for a formula, then you divide it by n minus r factorial, so that those get cancelled and the result remains the same. And you are dividing
Okay.
it by r factorial because the possibilities get repeated in the same way in case of a combination where the order doesn't matter, which does in case of a permutation.
Perfect, perfect. Exactly. So just to sum up what she said is 6 factorial by 2 factorial in this case, where we have 4 blanks and we have 6 letters, and the order doesn't matter. We just want a group of things. It doesn't matter if it's A, B, C, D or A, B, D, C or B, C, D, anything. It doesn't matter. So we just want a group of things. So order doesn't matter. So this is permutation in the case where order matters, 6 factorial by 2 factorial, and we divide it by 4 factorial because we only want combination. So that is how we derive this formula. Okay, I'll just leave this here. Okay, suppose we want to choose 11 students out of 100 students to make a soccer team. How do we do that? Okay. Yes, you can just unmute yourself and answer, I guess.
Okay, so we can use the formula of NCK. We'll use N as 100 and K as 11. So it will become 100C11.
100C11. Perfect. Now over here in this question, there's one more extra thing. We also want to select one team leader. So now what do? If we, out of those 11 people, we want one team leader.
We'll have so we have 11 people and one team leader. So we'll have 11 ways to choose that team leader.
Yeah, we
So the
multiplied by 11.
Yeah, so the total number of cases will be 100C11 multiplied by 11.
Perfect. Okay. What if I change this question to we want 2 people who will lead the team? So out of 100, I still have to select 11, but we need 2 leaders.
Then it'll be 100C11 times 11C2.
11C2, yeah.
Perfect, perfect. It will be 100C11 times 11C2. Okay, you guys are good at this. Read the next question. If there are a lot of you who know the answer, just type it in the chat box. I'll check it.
Privately or on to everyone?
I privately, if that's possible. Okay, all of you guys are correct. Those have messaged me. Okay, what about others? Do you understand the question? Yes, yes. Okay, everyone's getting the right answer. Okay, so we have a total of 12 students, 7 are girls, and we have 7 girls and we have 5 boys. Now we want to make a team of 4 girls and 3 boys. So out of the 7, we will choose 4 So we have all the 4 girls that we need, and out of the 5, we will choose 3. And then we multiply this, because out of all of the possibilities of the girl selection and out of all of the possibilities of the boy selection, they all go with each other. So we have to multiply. Okay, someone wrote 4C7. 4C7 means that out of 4, you're choosing 7, which is not possible. Like if you have only 4 chocolates, you cannot get 7 chocolates. So it has to be the other way around. There's no answer to this. There's no answer to this. It has to be 7C4.
It will become a fraction.
Yeah. Okay. Also, someone else wrote 12C4 into 12C3. So if the question would have been out of 12 students, we want to make a group of 7, 4 girls, 3 boys, total 7, then 12C7 would have been the correct answer. But over here we have specific criteria that out of the 7 girls, we want 4. So out of those 7 only, we want 4. Out of all the 12, we don't want 4. So in this case, what this means is out of the 7 girls and 5 boys, I can select 4 anyhow. So in 12C4, I'm also counting the possibility of boy 1, boy 2, boy 3, girl 1, which is not correct. We want 4 girls. Because 12 contains 7 girls as well as the 5 boys, and I'm selecting 4 out of them. I'm also counting the possibility of having boys in the group. So yeah. So the correct answer would be this. Okay. Yeah, I think everyone else all got it right. Okay. Read the next question and type the answer in the chat box. Okay, Devika, your answer is correct. Is there any way you can maybe simplify it? You can shorten out. It's a very long answer. It's correct. Just think of a better way of doing the same thing.
Okay. Should I simplify this or do it in another method?
Either ways, try both. Arya, same thing. You've also done the same thing. What you've done is correct, definitely, but you can maybe try simplifying it. It has a lot of terms. It's a very large equation. So, or you can try a different approach, which gives you a smaller equation.
Okay, sure.
Okay. Okay. Someone just wrote 8C4 into 5C4. So this means that out of the 8 girls, you're selecting 4 girls. So now you have 4 girls. And out of the 5 boys, you're selecting 4 boys. So you have 4 boys. Now you have a total of 8 people. We only want a total of 6 people. So is it a typing error, or check your answer again? The question states that there are 8 girls and there are 5 boys, and out of the 8 girls, we definitely want 2 girls, and out of the 5 boys, we definitely want 2 boys. But that is only 4, and we need a total team of 6. So the rest 2 could be either girl, boy, doesn't matter. There's no specific criteria. Okay. Again, as I said, out of the 8 girls, we definitely want 2. Out of the 5 boys, we definitely want 2. So one possibility could be girl, girl, boy, boy, girl, boy. So 3 girls, 3 boys in total. But we can also have the possibility of girl, girl, boy, boy, girl, girl, right? We can have 4 girls and 2 boys. That also like it also comes under the same specific criteria. We can also have girl, girl, boy, boy, and boy, boy, 4 boys and 2 girls. So where if you say 8C3 times 5C3, you're only considering the first option. Okay, Dhwani and Mridula, you have also done the same thing. You've taken these 3 cases, which is again, it's correct. It's definitely correct. Try maybe a different approach, which will shorten your answer. Or try doing some algebra and simplifying this. Okay, don't find the simplified answer in numbers. Just keep it in a C, or like keep it in 8C something and 5C something only. Just instead of 3 different terms, reduce it down to 1 term. I'll explain what I mean. Yeah. Okay, Kirti, again, your answer is correct. Try simplifying the 3 terms down to 1 term. Same for Sanika.
Okay.
Same, Meera. You have 3 terms. Your answer is correct, but try and reduce it down to 1 term. It's something into something plus something into something plus something into something. So
Yeah, even I got
try
the same
reducing.
type of answer.
Yeah. So everyone who's got that. Okay, so I'll explain that answer. So now we have 3 cases as we just saw. We definitely need 2 girls and 2 boys. And for the remaining 2, we can either have girl boy, or we can have girl girl, or we can have boy boy. So we'll take each of the cases separately. For the first case, where we have 3 girls and 3 boys, we get 8C3 times 5C3, because out of 8 we select 3, out of 5 we select 3, and we have this. For the second case, we have 4 girls and 2 boys. So in that case, out of 8, we select 4, and out of 5, we only select 2. And for the last third case, where we have 4 boys and 2 girls. So out of 8, we select the 2 girls, out of 5, we select the 4 boys. So it's 1 term, second term, third term, and addition. So this answer is correct, but maybe we can reduce it down to only 1 term. I'll give you a minute to think, otherwise I'll share.
Could you please show the question again?
Yeah. Okay, it's not visible. Sorry. Okay, does anyone have any ideas?
Could you
Okay.
wait for just 2 or 3 minutes more?
Okay, I'll wait for 1 more minute. Yes, Anushka, you raised your hand.
No, that was from before.
Okay, Urvi.
Actually, I have posted an answer. Could you please tell me, is that correct?
Yeah, that's correct.
Okay.
If nobody gets it, could you explain what you did?
Yeah, sure.
Okay. Meera, I don't understand your last answer. How did you get that?
First, I basically multiplied 8 into 5 and 3 into 3 plus 8 into 5 and then 4 into 2. Then 8 into 5, then 4 into 2. Then I added.
Okay, so what you're saying is over here you did 8 into 5, and then over here you did 3 into 3. So not divide. 8 into 5, C, 3 into 3, right? You cannot do that because the formula 8C3 actually means 8 factorial upon 3 factorial and 5 factorial multiplied by 5 factorial upon 3 factorial and 2 factorial. Right? And what is 8 factorial? 8 factorial is 8 into 7 into 6 into 5 into so on up to 1. And then 5 is 5 into 4 into 3 into 2, so on up to 1. So if you think about it, this comes up to 40. And 40 factorial would be 40 into 39 into 38 and so on up to 1. Whereas this is only 8 into 7 into 6 and 5 into 4 into 3. So it's very different numbers. You cannot multiply like that.
Oh, yeah.
Sanika, same. You cannot add or subtract or multiply the top numbers and the bottom numbers. That's not allowed because this essentially means factorial, right?
Oh, yes,
So it's in, yeah. Okay. Okay, I think Urvi, you can explain what you did.
Yeah. So my answer comes as 8 choose 2 into 5 choose 2 into 9 choose 2. So basically what I did was, here we are given that we need 2 girls and 2 boys definitely. So just make, I did it separately, like 8 choose 2 and 5 choose 2 because it is a definite case. Now what happens is we need a team of 6 and we are already done with 4 members. So I just subtracted it from the total number of children who are there. So it comes to be 9. Now I need to choose only 2, but because my team also has a limit, that is 6. So I did 9 choose 2. So ultimately the answer comes.
Yeah. Perfect. We have total 8 girls and 5 boys, so that is total of 13 people. And so first we select 2 girls out of the 8 girls, that is 8C2. Then we select 2 boys out of the 5 boys, that is 5C2. And out of the 13 people, we've already selected 4 people. So now there are 9 people remaining, and from that we select the last 2 members of the team.
Ma'am, I had a doubt.
Yeah.
Yeah, so I had also originally tried it with this 8C2, 5C2, 9C2. I think I had also sent it. But then after you had written this 8C3 times 5C3 down, I started trying with that. So Can you also just explain how we can get the same answer using this original thing we have here, 8c3 times 5c3 plus
Okay.
that one?
Okay, yes. I'm sorry, I might have missed your message. So essentially, both of these things are the same thing. If you work it out, if you multiply all the numbers and then find out the values of the individual terms, and then if you add them, you'll finally get the same answer. If you want, we can do that right now very quickly and check that if these two answers are same or not, but it will come the same. Yeah. So this is just a different approach of doing the same thing.
Yeah,
Okay, ma'am.
basically first we have to choose 3 girls and 3 boys. That is the first case. Second case, 4 girls and 2 boys, and the third case is 2 girls and 4 boys. So we just find out the separate answers for all 3 cases and add them up.
Okay. A few people joined late, so we have not covered a lot. We were just doing a quick revision of combinatorics, permutation, and combination. We did 1 or 2 questions. Okay. Try this question.
That above team of 6, right?
Yeah, that's off.
The team we have just now made of girls and boys.
No criteria. It could be either ways.
Okay.
Just into 2 smaller groups.
So it's just a team of 6 from 13 people, and after that, you have to make 2 groups of 3.
Yes.
All right.
It's an extension of the previous question. If you get the answer, just message me in the chat box.
Ma'am, so there's nothing special about this above team of 6, right? Can we also take the question as in how many ways can we divide a group of 6 people into 2 groups of 3?
No. It's the extension of this question. So over here, out of the 8 girls and 5 boys, we made a team of 6, which definitely had 2 girls and 2 boys. It's continuation of that question.
Okay, ma'am.
So from that team of 6, further divided into 3 and 3.
So that conditions is still imposed on this question.
Yes.
All right.
Uh,
All right.
So this is compulsory and total team of 6. Team of 6 that we further divide into 3 and 3.
There's no rule like in the team of 3 there should be 2 girls and 1 boy.
No rule. It could be either ways. Yes, Kirti, that's correct. Urvi, is that add like multiply to the original formula?
Yeah, like
Yeah, okay. Arya, can you explain your answer? Like, what approach did you take?
Yeah, so it like similar to like what method Urvi did for the previous sum. Instead of having 6 people in a group, now we have 3 people in a group. So out of the 3 people in a group, I took that out of those 8 girls, we can have any one group in a like one girl in a particular group at a given time, and another one boy in that same group of 3, and another one which can be either of a girl or a boy, and similarly in the other group of 3. Then another possibility could be, so that comes out to as 8C1 into 5C1 into 11C1, because this time we have 11 possibilities and not 9, because only one of the girl and boy has been used up.
Yeah.
And the second case could be 2 girls at a time in a group of 3 and 1 boy. So that is 8C2 multiplied by 5C1. And another possibility could be only 1 girl and 2 boys taken at a time. So sorry, it should not be 11C2 but 5C2 at the end, the answer which I've sent to you.
Okay. And why did you multiply the whole thing by 2?
Because so there are groups of 3 and twice of that, like the total number of
No, I think that will not be required because all the residual people will go in the other group.
Not exactly. So what approach Arya is trying to take is you can either have one girl, one boy, and then the remaining person could be either a girl or a boy, or you can have 2 girls and what was the second case? 2 girls and
2 girls,
girls.
1 boy, and the third one 1 girl, 2 boys.
One boy and one girl.
one girl
One boy.
and 2 boys. But then that nullifies this case because these are the only 2 cases. If it's one girl, one boy, one girl, that means it's this case. And if it's one girl, one boy, one boy,
Yeah,
then
this is like both these cases.
yeah. So you'll only have
Yes.
to consider 2 cases. Another thing is, if suppose we consider cases like this, then first, okay, out of the 8 girls, we select 2. Out of the 5 boys, we select 1. And then for the next group, out of the remaining 6 girls, you select 2. And out of the remaining 5, okay, no, remaining 4 boys, you select 1. But so you'll have to do this. There's one more thing that is, you'll have to consider more cases because it could be 2 girls, 1 boy in the first group of 3, and in the second group of 3 you could have 3 boys.
Yeah, because on the top we have like even a team with 4 boys and 2 girls.
Yeah, there was 2 girls and 4 boys. So you can definitely go about it in this way, but you'll have to consider a lot of cases. For each
Yeah,
of
right.
these, you'll have tons of cases. So try a different approach.
Okay.
Okay, anyone else who has any different approaches or kind of knows what to do?
I have some idea. I'm not sure if it's correct. So can we first take we choose the 6 students in 8C2 times 5C2 times 9C2 ways, and then out of that we have to choose any 3. So can we do it like 8C2 times 5C2 times 9C2, the whole thing C3?
Oh, okay. That's you were almost there. That's actually what we have to do. I'm sorry, I'll just share the answer because we have to cover a lot of things. So in the previous question, we got the answer as 8C2 times 5C2 times 9C2 because 2 girls, 2 boys, and out of the remaining, we need 2 more people. Now, what Anushka said was we will do this whole thing C3 because this gives us all of the possibilities of selecting 6 people, and now we want out of those 6 people we want to select 3. But the thing is, this gives us the number of possibilities. What we want to do is we want to select 3 people out of 6. So we want to do 6C3. Out of 6 people, we want to select 3. But this gives us possibilities. So this will be a very large number. And if you do C3, you'll get an even larger number. Because we want to do 6C3. So all of these possibilities multiplied by 6C3. Out of these 6 people, I can select 3 of them in these many different ways. There are these many different ways to select 6 people. And then out of all of, in each and every one of these ways, there are these many number of ways to select 3.
Okay, I thought about this before, but I thought that might not be correct. Then I skipped that.
Yeah, that's okay. Did everyone understand this? So we'll multiply the initial answer by 63. Everyone understood, or if you have any doubts?
In that case, there may be repetition, right?
No, there won't be repetition. The first step, what we are doing is we are just selecting 6 people out of all of the students. And the second step is we are dividing those 6 people into group 1 and group 2. Does that make sense?
Yeah.
There'll be repetition if we do the same step twice. These are two different things that we are doing. Okay. If you have any doubts, you can always message me or just raise your hand. Do you know what is a Pascal's triangle?
Yeah, I do.
Yeah.
So you've done it in this camp, or you just?
I know it generally.
Okay.
They usually take it up just as a fun activity. So
Okay, so Pascal's triangle is actually a very fun thing to create. What we do is we start off with a single one, and then in each row we add 1 to the start and to the end. We begin and end with a 1, and all the numbers in between is the addition of the above 2 numbers. So 1 plus 1 gives us 2, 1 plus 2 gives us 3, 2 plus 1 gives us 3, then 3 and 3 gives me 6, 1 and 3 gives me 4, and so on. So over here 10 and 10 gives me 20, 15 and 20 gives me 35. And since there's no way to stop this, this goes on forever. You can have an infinite number of rows in this triangle. So that is just a basic way of how to construct a Pascal's triangle. You start with ones on either sides, and then every 2 numbers you sum it up and write the answer in the middle. So 1 and 1 gives you 2, then 3, 3, 4, 6, 4, and so on. Now, another way to interpret this Pascal's triangle is, okay, I need space. You can also write it as the kth number of the nth row is n choose k. So, okay, let's take, for example, the 4th row. So we have 4C0, 4C1, 4C2, 4C3, 4C4. If you calculate 4C0, you get 4. If you calculate 4C1, if you calculate this, you get 1. Over here, you get 4. Here, you get 6, 4, and 1. If you just write down the factorials and multiply and divide, you get this as the answer. And this is the 4th row. 1, 4, 6, 4, 1. Try it for a few rows. Take the 3rd row, 5th row, 6th row. Just try it out.
I didn't understand as to what you said now. Can you repeat it?
Yes, of course. So what I said is, these are different rows, right? This is the 1st row, 2nd row, 3rd row, 4th row. In the Pascal's triangle, we will start with the 0th row because we want the number 4 in the 4th row. We want the number 5 in the 5th row, number 6 in the 6th row. So we start with the 0th row. That might get a little confusing.
It's like 11 square, 11 cube, and 11.
That is also another pattern, yes. So this is the 0th row. This is the 1st row. This is the 2nd row, 3rd row, 4th row, and so on. Now, if we consider the second row, for example, it is 1, 2, 1. And again, since the way we started with the 0th row, the first number will be the 0th number. And then we have the first number and then we have the second number. So let's see, we have, I'm erasing this. We have 2C0. From the second row, we want the 0th number. So 2C0, which is 2 factorial upon 0 factorial 2 minus 0 factorial, which is 2 into 1 upon 1 into 2 into 1, which is 1. So 2C0, we get 1, which is the first number. 2C1 is 2 factorial upon 1 factorial 1 factorial, which is 2 into 1 and divided by 1 into 1, that is 2. So we get the second number. Similarly, if I try 2C2, I get 2 factorial upon 2 factorial 0 factorial, which is nothing but 1. So I get the third number 1. If you do this for the fifth row, this will be 5C0, this will be 5C1, 5C2, 5C3, 5C4, 5C5. If you do it for the 10th row, again, it will be true. If you do it for the 50th row, it will still be true. They always follow this pattern.
I have a doubt. How is 5C 2 equal to 5C3 then?
That's a good question. We'll come to that. That's actually one of the questions we have to solve. So I'll come back to that. Okay. Anyone has any questions about this? How the kth number of the nth row is NCK in the Pascal's triangle? Arya.
Not a question about like the specific formula, but the 11th power, I think it doesn't follow after 14641.
Oh, okay. Yeah. So someone mentioned that this is powers of 11. Wait, I'll erase these markings. So it actually does follow even after the fourth row. So 11 power 0, 11 power 0 is 1. 11 power 1 is 11. 11 squared is 121. So see, you have 120. You have 1, 11, 121. 11 cube is 1331. So you have 1331. Then you have 14641. Now 11 to the power 5. When you try to do 11 to the power 5, you get 161051, I think. Which okay, I need space. In the Pascal's triangle, I have 1, 5, 10, 10, 5, 1. Now, if I put this 1 as a carryover and this 1 as a carryover, I get 161051.
Oh, okay. That's interesting.
So, yeah. So for the power 7, I have 1, 7, 21, 35, 35, 21, 7, 1. So I write 1, 7, 1. This 2 goes as a carryover. So again, 7. 3 is a carryover. So 8. 3 carryover. So 4. 2 carryover. So 9, 1. So this is 11 power 7. I might have gone a little fast, but we are just taking the tens place and carrying it over to the next number.
Okay.
So the 11 power works for nth row also. Okay. I hope everyone understood this part because we'll be using that over and over again. The last sentence, this sentence.
Yeah.
Yes. One thing to remember, we start with the 0th row and this column, if you want, if you can call, I think column works. This is the 0th number. So the first one will actually be 0C0. And to make sense of this intuitively, you have 0 things and out of that you are selecting 0 things. You have nothing and you're selecting nothing. So there's only one way to do it. You do nothing. So that's why it's 1 and not 0. Or for example, this one. This will be 3C0. So you have 3 items and out of that you have to select nothing. So there's only one way to do it. You do nothing.
Okay.
So yeah. Okay. This was one of the questions. What is n and k for the first row, which I just mentioned? N and k for the first row is 0 and 0. It's 0C0, which is 1. That can be a little tricky. Okay, does anybody have any ideas why the triangle was symmetrical? Someone observed that the triangle was symmetrical. So, okay, yeah. If you draw a line of symmetry over here, all the numbers are identical. So any idea why or how?
Yeah, I think I have some idea.
Okay. Is it short that you can write it in the chat box, or give me 2-3 minutes so that everyone can think, and then you can check.
Okay, yeah. Okay, I'll try to write it in the chat box.
Perfect.
Can you please repeat the question? I was out of the meeting for a minute.
Okay, and the question is that the Pascal's triangle has a line of symmetry. If you draw a line along the center, you observe that the numbers on the left hand side and the right hand side are the same. So any ideas why it's symmetrical? Dwani, that's true, but why are there no equal numbers? Like, why is this? Why do you get 5 here as well as here? Why do you get 21 here as well as here? Why does that happen?
I wanted to ask this. It may be out of the Pascal's triangle, but how is proving this connected with proof by story?
Oh yes. So proof by story, mainly we can use that in combinatorics whenever n choose k is involved, and having the Pascal's triangle will make it a little easier because it's a visualization. It makes it a lot more intuitive. So I'll do the symmetry part of it, and then you'll understand why we are doing the Pascal's triangle.
Okay.
There are lots of patterns that you can use. Yes, Anushka, that makes sense. Yes. So, okay, so to prove that there's a line of symmetry, there are more than like 5-6 proofs. So if you get one, try to think of another way to prove the same thing. You can do it logically, you can do it algebraically, you can do it using combinatorics, or you can even make a story. You can have characters and tasks. And yes, Arya, that's correct. Yes, Simran, that's correct. So what you did was you tried to use logic and you observed a pattern and you saw that you observed the pattern, you try to use logic. Try a different approach, try algebraically or something else. Anushka, you have a question?
No, I wanted to answer this one. So.
Okay. Okay, others, do you have any ideas of why is it symmetrical? Yes, Urvi.
I think it's simply because of combinatorics, like since we have simplified it for the kth term of the nth row. So I think we can get it. Actually, I'm trying to simplify it that n choose A is equal to n choose, I'm not getting the exact term, but it comes equal. So,
Yeah, you're on the right track.
Yeah, so by that, it should be symmetrical.
Yes, that's the right track. Keep working on it. Yes, Anushka.
Yes, I have also thought about the same thing. So I know one theorem. I don't know if it's a theorem or I just know one identity that if we have NCK, so we can say that NCK is equal to NC n minus K. Therefore, this is true. So if we have K and then the opposite over there will be n minus K. So therefore, it will be true.
Yes. That's correct. So this is what Anushka and Urvi, both of them were saying is that let's see 5, for example. 5 on this side is 5 choose 1, whereas 5 on this side is 5 choose 4, and they are equal. Why? Because, okay, let's try to simplify 5C1. 5C1 will be 5C1 will be 5 factorial upon 1 factorial and 4 factorial because 5 minus 1. And 5C4 will be 5 factorial upon 4 factorial into 5 minus 4, 1 factorial. So essentially we have the same thing. We have 5 factorial in the numerator and 4 factorial and 1 factorial in the denominator. So it's basically the same thing. It's just different ways of writing it. Or if you see 21, for example, that is 7C2 and 7C5, which is again the same thing. Both of them are 7 factorial upon 2 factorial into 5 factorial. It's just different ways of writing it. Now, over here, what we did was we tried to use algebra and prove that both of these are equal. I have one more approach. Now, assume you have, again, 5 students and you have to, okay, let's do 7. You have 7 students and you have to make a team of 2 students. So how can you do that? You do that by 7C2. Now, instead of making a team, let's this time what we are going to do is we'll keep rejecting people until we are left with 2. So I have 7 people. I reject the first, second, third, fourth, fifth person until I'm left with the final 2. So how do I select 5 people to reject? That is 7C5.
7C5.
Yeah. So selecting 2 is same as rejecting 5. So 7C2 is same as 7C5. And so this is the kind of stories we'll be making. They won't be very elaborate and creative, but yeah, it won't involve a lot of math. It will be intuitive and yeah. So it's symmetrical because NCK equal to NCN minus K, where both of them equal to n factorial upon n minus k factorial, or it's selecting k people is same as rejecting n minus k people. And the most basic approach that is we first start off with a 1 and then every time we add 1 and 1 to the start and the end, and all the numbers in between are just addition of the previous two numbers. So over here I get 2, and then 1 plus 2 gives me 3, 1 plus 2 gives me 3. So once it starts off as symmetrical, it has to continue being symmetrical, because the middle numbers are just additions. So whatever will happen on the left hand side, the same thing will happen on the right hand side, and we are adding ones to both the sides. So logically, if it starts symmetrical, it has to continue being symmetrical. So there are 3 different ways to prove this. Okay, now
I
let's
didn't
try.
understand selecting k and rejecting n minus k.
Oh, okay. Let's say you have 5 people and you have to select 2 of them. So out of 5 people, you select 2 and 5 C2 ways. Yes.
Yes.
Now, instead of selecting 2, there are 5 students as a teacher. Instead of selecting 2, what the teacher does is, I don't want person A, I don't want person B, I don't want person C.
So I reject 3.
Yeah, so if the teacher rejects 3, automatically you're left with 2.
Okay.
So
Got it.
that's 5C3. Okay. Does anybody have any doubts so far? Okay, perfect. We'll move on. Now the next question is, prove that each number is the sum of the 2 numbers above it, which was the idea of how we made the Pascal's triangle. 10 plus 10 gave us 20, or 20 and 15 gave us 35. So now try to prove this again using different methods, combinatorics or make a story.
Okay.
Can you please explain what's proof by story again?
Okay, yes. So proof by story is over here, like selecting k people is same as rejecting n minus k. So instead of using any math, what we did was we made up a story that there are 5 students and then there's a teacher selecting 2, or teacher is rejecting 3. Selecting 2 is 5C2, rejecting 3 is 5C3. So that's why it has to be equal. It isn't exactly the very creative type of story, but there's some particular task that you have to perform, and you can do it in 2 different ways.
So
One
you're
of the ways
imagining,
will be the LHS and one of the ways will be the RHS, and that is how you will know it's equal
so you're
with the
sort of
same task.
imagining a scenario in which it works.
Yes, exactly.
All right.
Can you go back to like the triangle?
Yeah.
I mean, that's what we did. So what do we have to prove over here?
What are the 3
So
things
we
to
have
be
to
proved?
prove why does that
Okay.
work using some other approach.
Yeah, I'm just working on it.
Try making up a story. Like even combinatorics approach will work if you try NCK and then.
Yeah, that's what I did.
Actually, we have made up this triangle only by adding these numbers, right?
Yes, of course, I know. So that is how we have made it. So it has to be true. But use this identity or use combinatorics or maybe make a story to also say that it's true. So different ways of proving the same thing.
No, I got away.
Yes, who is that?
It's Shrutika.
Okay, hi. Tell me.
Yeah, so for example, I'm taking one in the numbers 1, 2, and 3, which is in the row the second row and the third row. So I can say 2C0 plus 2C1 should be 3C1.
Yes, that is what you have to prove. 2C0 plus 2C1.
So if we work it out, it will be. I mean, it is.
Yeah, of course it has to be because that is how we have constructed it. But what if we have to prove NCK plus NCK plus 1 is equal to N plus 1 CK plus 1 for a general term? You cannot work it out for a general term.
Okay.
Okay, it has to be true because that is how we have constructed the triangle. So we definitely know it's true. If we try, we can just say that is how we got it. So it has to be true, but try different approaches. That is what we're trying to do here. Mainly try to find out a story if you can. Usually for stories, you can take girls and boys if you have two separate numbers, or if it's just basic n and k, it's usually selecting k people out of n people, and you'll get your story.
Okay, so I've got another idea. I just made this combination thing into a story.
Okay,
So
okay, tell me.
if we take like we're choosing no one from two people, so you can do that in one way. And I'm also choosing one person from two people, so I can do that in two ways.
Yeah.
So totally, so I've got three ways now, so which is similar to choosing one person from three people.
It kind of makes sense, but it does the same thing work for maybe if you try 4, 6, and 10. It won't work for that. Of choosing two people out of four, choosing three people out of four, how do you equate that to choosing three people out of five?
I also have an idea.
Yeah.
Can we have something like the table of 11 to do this? So basically we have seen this is the power of 11, and in 11, if we have some 11x, that is basically 10x plus x. So if we have any number, the last digit of 10x will be 0. And when we are adding that x, it will basically be the last digit of that number x. So over here it's always 1. So that is 1. So therefore we are adding, like, keeping 1 over there. And then when we are adding the number, like the second digit of x to the second digit of 10x, so something is coming, so it's coming like 1 plus 2 or 1 plus 3 and something like that. So therefore I think maybe
Yes, that is, you can definitely try it that way. Try it, let me know if that works. I won't be focusing on that right now because I want to do proof by story. There are a few more questions that I want to complete before 5:30. But yeah, let me know if that works. Okay, so I'll give you, I'll tell the answer to this so that you get a better idea of what we actually are trying to do. Now, basically what we want to prove is that, I've written it down over here, I'll write it in a better way. If you see two numbers, you have NCK, then you have the number beside it. So that is NCK plus 1 in the same row, but the number beside it. So it becomes K plus 1. And it equals to the number below it. It equals to the number below it. So below row will be, the row under it will be N plus 1. And C, we will get K plus 1. Let's see over here. This is 4C2, this is 4C3, adds up to be 5C3. Sorry, this is 4C1 and 4C2, we get it to be 5C2. Sorry, 4C1, 4C2, 5C2. This is 6012. 363, 64 gives us 7C4. Yeah. So, okay, I'll write it down in numbers first. 6C3 plus 6C4 gives us 7C4. This is our question. Let's try to prove this, then we'll go to the generalization. 63 was 20, 15, and 35. So this is 20, this is 15 and 35, just for reference. Now our story will be something along this lines. We have 7 students and out of them we want to select 4. So there are 7 students out of which I want to select 4. Now let's consider there's this one girl named Sarah. So there are 2 possibilities, and out of the group of 4, Sarah is either a part of the group or she is not a part of the group. So let's consider the first case where she is a part of the group. If Sarah is a part of the group, we already have 1 member. So out of the remaining 6 people, we want to select 3 more people. This is out of 6, we select 3 more, plus we already have Sarah. And in the second case, where she is not a part of the 4 people, out of the remaining 6 people, we want to select 4. Does this make sense? Total, there are 7 students and I want to select 4 of them. One possibility, Sarah is a part of these 4 people. So then out of the remaining 6, I have to only select 3. And another possibility, Sarah is not a part of it. So that means that out of the remaining 6, I still have to select 4. So we get 63 plus 64 gives us 7C4. Did everyone understand this?
Yeah.
Yes.
So we didn't actually do any math. We just made up a story. Now, if we want to
Once again,
generalize
can you
this,
please explain that?
yes, okay. Let's take letters. We have A, B, C, D, E, F, G. We have total 7 people. Let's say G is Sarah. Okay. And we want to select 4 out of these 7 people. We are going to select 4 out of these 7 people. One possibility is we select Sarah for sure. And then we still have 3 more places left. To fill up these 3 more places, we have 6 more people left. So out of those 6, I will select 3. Yes. And this was the first case. The second case is Sarah is not a part of the group. So there are still 4 more places left. But this time again, it's only out of 6 people because Sarah is not a part of the group. We are not considering her. So this time out of 6, we have to select 4.
Okay.
Yes.
But I have a question, but why is it that we're taking Sarah as like a person or something like that?
Okay, that was just an example. And we are taking her because, so we are taking one person to be the constant, and that person is either a part of the group or not a part of the group. We are taking those 2 cases.
Okay.
There's no explanation of how to come up with this story. You just have to get a lot of practice and think about it. But once you do, it's much more easier than mathematically solving it. Okay, so this was one of the stories. Does anybody have any doubts so far? Okay.
No.
Okay, this is a fun activity. We can do this. Okay, let's do this quickly. Over here, what we have to do is write down the Pascal's triangle and color all the numbers that are even. So everybody just write down the Pascal's triangle up to 10 or 12 rows and color all of the numbers that are even. Even I'll do it over here simultaneously.
Actually, while working on the previous question, this sort of just occurred to me, and I did it, and I tried it on like this website that I found that helps you make big rows of the Pascal's triangle, and it ends up looking something like the Sierpinski triangle.
Yes, okay. So, yeah,
Ends up
that's it.
looking like what?
Try making it. We'll see what it looks like. Okay. Everyone try doing this. I'll share my screen in 1 second.
I had a doubt actually in the previous problem which we discussed.
Yes.
So is there any like other than proof by story? Is there like no other method by which we can do that?
No, there is. Okay. So I'll share that too.
Isn't like nck plus nck plus 1 is equal to n plus 1 ck plus 1 a similar like a proof?
Yeah. That's the, okay. So I'll also do that. So this is the generalized equation over here. This. What to prove this algebraically, what you can do is you can split this up into n factorial upon k factorial, n minus k factorial, and similarly split this term and split this term. Take LCM in the of the denominator. LCM of the denominator and add the numerators. The LHS will be equal to the RHS.
I mean, just by
Okay.
computing.
Because then I tried to substitute n plus 1 factorial by n factorial into n plus 1 and like try to simplify it further, but then in the end I'm getting not like ideally we should get n plus 1 factorial in the numerator, but I'm getting it as n factorial into n and not n plus 1, so I was a bit confused in that part.
Okay, I'll write down the proof over here quickly. Till the time everybody, you can keep drawing the Pascal's triangle. Draw it up to 10 rows, that should be enough. Okay. Okay, everybody just look here for a minute and then you can go back to drawing the triangle. So over here, this was our generalized equation, and this is the first term and the second term. I have simplified the first and the second term. So I have it in terms of factorial. And in factorials, 7 factorial will be 7 into 6 into 5 into 4 into 3 into 2 into 1. And 8 factorial will be 8 into 7 into and so on. So 8 factorial, I can also write as 8 into 7 factorial, because it is 8 into 7 into so on. So if I just do 1 to 7, that's 7 factorial, and then there's 8 extra, right? So over here I have k factorial, here I have k plus 1 factorial. So to convert k into k plus 1 factorial, I have multiplied an extra k plus 1. And then I have n minus k factorial and n minus k minus 1. So n minus k is greater than n minus k minus 1. This is 1 less than n minus k. This is 1 less than n minus k. So to convert n minus k minus 1 to n minus k, I'm multiplying this n minus k, n minus k. And here I was multiplying k plus 1 to numerator, denominator, numerator, denominator. So that helps me take the LCM. Now the denominator is k into k factorial into k plus 1 is k plus 1 factorial. We already have k plus 1 factorial here. And n minus k factorial we have here. And over here, this multiplied by this will give us n minus k. So finally, there's LCM in the denominator, and in the numerator, n factorial, you can take common, and remaining you have k plus 1 and n minus k. So k plus 1 plus n minus k. K cancel, you have n plus 1 left. So n factorial into n plus 1 is nothing but n plus 1 factorial. I'll definitely share a PDF of this at the end so you can go through it slowly, take your time. But you can also find this proof on the internet.
Yeah.
But this is the algebra proof of it. This is so much more complicated and you're more likely to make mistakes. Okay, the Pascal's triangle. Does anybody have the 8th row, 9th row, 10th row ready?
Yeah, I have 8th and 9th.
Yes.
Yeah.
Okay, so and just any one of
28,
them.
46, 70, 46.
56.
56.
Oh, yeah, sorry, 56.
70,
70, 56, 28, 8, 1.
8 and 1.
1,
1, 9, 36,
36,
36,
84,
84,
126 and the same thing repeats.
Yes.
And last row.
1,
10,
45,
45, 120, 210,
252.
252.
And then
Yes.
repeats.
Okay. Now quickly, I'll just color all the even numbers. Okay.
even 10 and 10.
Let's.
Ma'am, in the 2 6s as well, in the 1 6 15.
That one.
Yeah, I think I got it. Okay. Now, if you observe over here, there's this small triangle. This makes a triangle, actually. This makes a triangle. This makes a triangle. This will go down and make a bigger triangle. This will also make a triangle. This will also make a triangle. I'll show you an image that will make it clear. Look at this. In this case, they have colored all the odd numbers, but this is the continuous pattern that you'll observe. It will be inverted triangles and yeah.
This diagram kind of appears in some exams.
Oh, okay.
I mean, not with the numbers, but they told to they tell to find the area of the black region, white region, something like that.
Right. Okay. Yeah.
I've seen this.
Okay. This is a better example. Right. Okay, I can't. How do I enlarge this? Can you see what is going on in the screen? It's basically a bigger Pascal's triangle and they've just colored all the numbers. So you can see that the triangles will continue going on like this forever. There'll always be one bigger triangle in the center and then smaller triangles on each side. And then you'll get an even bigger triangle in the center and then smaller triangles on each side. Like this.
Yeah.
This is all same. So yeah, that is the activity about the Pascal's triangle. Okay, is it okay if I extend the class by 10 minutes, 15 minutes?
Yes.
Yes.
Yeah, no problem.
Remember when I said that out of n things, if you have to select 0 things, you can only do it in one possible way. That is, you do nothing because you have to do nothing. So that was actually the first of this example. Over here, what we are doing is NC 0. Out of n, we are selecting 0. And how do we get 1? That is, usually people get confused because 0 factorial is equal to 1, which is not exactly, it does not make sense. 7 factorial is 7 into 6 into 5 into 4 and so on up to 1. But 0 is less than 1, so you cannot have up to 1. So 0 factorial intuitively does not make sense. So for things like NC0, it's easier to understand it by a story. So the story was, out of n things, you have to select 0, you have to do nothing. So we do nothing. Can you come up with a similar story for NCN?
From n things, you're selecting n, which is, you have only one way to do that. So it will be 1.
There is only one way in which you can select everything.
You
You
have
just
one
select
girl,
everything.
Exactly.
select that girl. So you have only one way to select that girl.
Exactly. There's only one way to do it. You select everything and perfect. What about NC1? Why is NC1 N?
Yeah, I didn't get this.
If we have 10 things and we have to select only one, we have 10 ways to select each of them.
Yeah, exactly. We have n items and we have to
Okay,
select only one. So I can select the first or the second or the third or the fourth or the nth. So there's n ways to do it. And what about the last one? N choose n minus one.
So you just don't have to choose one object
You-
in that
you
case,
just
and you can
reject
do
one.
it in different ways, because
Exactly.
And
All of
you
you are right. So
You
out of
reject
n things, I have to select n minus one things. So that means I'm rejecting the one item, and that I can do it in n ways. I either not take the first and the remaining n minus one, or I not take the second and the remaining n minus one, and so on. So these are a few intuitive specific combinations. Okay. Vandermoor's identity. I don't know how to pronounce his name, but this is an identity, and we'll try to prove this identity by using a story. Now, this identity states that summation. Does everyone know what is summation?
Yeah.
Yeah.
yes.
Anyone who doesn't know what is summation?
I don't know.
Okay. So summation is basically, suppose you're doing 1 plus 2 plus 3 plus 4, addition this time, plus 5, and so on up to 10. So instead of writing it over and over again, we can just write summation of n, where n goes from 1 to 10. So that means when n is 1, I put 1, then next number n is 2, so I add 2, then next number n is 3, so I add 3, and so on up to 10.
Okay, got it. Thank you.
Or it can also be something like 2 to the power n and summation of n equal to 1 to 3, for example. So that means n is equal to 1, so 2 power 1, n equal to 2, 2 power 2, n equal to 3, 2 power 3, and whatever the answer is. So instead of writing big equations all over again, when there's a very obvious pattern, we can just write summation instead. And summation only applies to addition. You cannot use it for multiplication or subtraction or division. So summation and okay, just a second. Summation of A choose K and B choose C minus K, and summation goes from K equal to 0 to K equal to C. So that means A choose 0 times B choose C, A choose 1 times B choose C minus 1, plus A choose 2 times B choose C minus 2, and so on. We keep doing this up to A choose C, B choose 0. A and B are some random numbers. It could be 4 and 5, for example. So in case of 4 and 5, it will be 4C0, 5C, let's take 3, plus 4C1, 5C2, plus 4C2, 5C1, and finally 4C3, 5C0. This is what it means. Now we have to prove that
So
this.
until it comes till 0, right?
Sorry?
I mean, like the last number should be 0.
Yeah. It starts from 0 in the first bracket and ends with 0 in the last bracket.
Okay.
Now we have to prove that this is equal to 9C3. Over here, if you observe what they have done is it's A plus B gives you A plus B and K plus C minus K. K plus C minus K, K cancel, you get C. So it looks very intuitive and yeah, you aren't actually allowed to do this. This is combinatorics and it is multiplication. You cannot add the numbers in the brackets, but in this case you can, because it's an identity, and we'll be seeing how to prove that using a story. So I'll Should I give you 1 minute or should I just tell you how to prove it with the story since it's late? Okay. I'll show you how to
Put
prove
an
it
A
using
and
the
B over here.
A, B, and C, all of them are constants. So in this case, for example, we took our A to be 4, B to be 5, and C to be 3. So in the first case, out of 4 things, I'm selecting 0. Out of 5 things, I'm selecting 3. Then 4 में से I'm selecting 1, 5 में से I'm selecting 2. Then 4 में से 2, 5 में से 1, and so on.
Okay, but like A and B can, like A and B depend on C.
No.
Okay, we can just take any terms to be A, B.
This could be 14, 15, 14, 15, 14, 15. So out of 14, I'm selecting 0, and out of 15, I'm selecting 3. It would not make a difference. The identity would remain the same. Okay. Do you remember the very first question we did where there were 8 girls and 5 boys, and we had to make a group of 6 people?
Yeah.
Yes.
In that case, we did something similar. Let's go there. See, look at this. It goes from, okay, if I write it like this, 8C2 into 5C3, sorry, 5C4. Then 8C3, 5C3, and then 8C4, 5C2. It goes in the same ascending descending order. 2,
Yeah.
3, 4, 4, 3, 2. So try to use this same story. This is the story. The question was actually a story. So try to use the same story to see if the other question makes sense. In this case, forget the identity for now. Forget the identity for now. Just try to prove it using these numbers with 4, 5, and 3, and then we'll see about the identity. Okay, we can do one thing. I have the next lecture also, the next week also I have another lecture. We can continue this in the next lecture. Till the time you can take it as a homework. I'll share the entire PDF with you.
I just got like the starting. Can we say like there are 9 students, 4 girls and 5 boys?
Yes, exactly. That's it.
I think I need to make a team of 3, right?
Yeah.
Okay.
Okay. So everybody still try to think over this as homework, but I'll give you a small hint. As she said, you have total 9 students, 4 girls and 5 boys, and you're trying to make a team of 3.
Yeah.
Okay. Work it out and see why it works, and if you want, write down the story. Yeah. Anybody has any questions so far?
No.
Yeah.
You'll be sharing this, right?
Yes. So in the next lecture, we'll properly see, there are a few more questions that we'll prove using stories. Yeah. Okay. If anybody has any questions, you can stay back or you can try thinking about this identity. And if you are done, if you got how we proved it using 4, 5, and 9, try to do the same thing with generalized A, B, C, K.
I wanted to ask, so in this case, can C be negative?
Oh, no. So in combinatorics, it's about choosing and arranging things, right? So you cannot have negative items. Just think about it as there are 10 things you're choosing 4. You cannot choose -4.
Okay.
If anybody has any questions, I'm here. Otherwise, I think you can leave. We'll continue this in the next lecture. I'll share the PDF and try to use the same question we did above to prove this identity.
Okay. Thank you.
Thank you, ma'am.
Thank you.
You.
Bye, ma'am. Thank you.
Thank you, ma'am. Bye, ma'am.
Thank you, ma'am. Bye.